shrinkage stopping makes use of what we call swell, and that we explain swell as the increase in the volume of a material. And every material, depending on the type of material you are handling, it has got its swell factor. Some materials, when you tamper with them or you begin to excavate them, the volume of the in-situ material will increase by a factor of 0.2. That is 20% or 10% or 15% or 30%. So depending on the swell factor, any material may increase in volume. So with the shrinkage stopping, we do our development as usual. And after we have created all accesses and designed how we are going to target or tackle the ore or the deposits within the various stopes or the blocks we have sectioned to take the ore from, we get in there and we work overhand. I explained these terms. We work overhand most of the time. So we stand on a platform. If one wants to work overhand, you will definitely stand on a platform and do your drilling above you. And so whilst you are up there doing the drilling above you, you need the platform. And so usually when you have done the drilling and you blast the material down. So let's say you do the blasting and these are the materials you have. That volume or that space you created to stand and do the drilling, it is filled up with the material. And if you extract every material, that is the blasted muck, all of it out of the stope, it will be hard to find a platform upon which you will stand and continue with your drilling. And so for this reason, the shrinkage stopping is using shrink, as in the laying explanation of the word shrink. You will try to reduce the quantity of the material within the stope and then leave a section of that. And usually we extract about 30 to 40% of the material you have blasted, leaving the remaining 60 or 70, depending on what percentage you took out. Then the remaining 60 becomes the platform upon which you stand and continue your drilling. And until you are done with the whole of the stope, you continue to leave this material in the stope until you are done. So when you are done, you can then extract all of the blasted muck out. And this is how the shrinkage stopping operates. So usually, if you are dealing with this type of stopping, you need to be sure that the material you are dealing with is not a reactive material. That is, the ore doesn't react with oxygen or other substances to create some poisonous gases that will harm you. And so if it is like that, shrinkage stopping is not an ideal situation, because you are going to stand on top of the blasted muck to do your activities. And again, this particular method has another disadvantage, such that how can I blast 100% and I can only take 40 maximum? So it means that if you are hungry for your deposits or your blasted muck, this kind of method wouldn't suit you. You wouldn't want to go for. So that is that for shrinkage stopping. So this is the technique here. So you do the drilling up. This is the broken ore. You stand on it, extract a portion of it out, then you leave the rest, and later you stand here again and do the drilling. So that is just the process for this type of ore. Then we have the long hole. The long hole, it says the long hole stopping is this, as the name suggests, uses holes drilled by a production drill. Yes, most of the time it is by hand. It is by hand. Hardly do we mechanize shrinkage stopping. But then, Priscilla, I remember yesterday mentioning something called an Alimak or something like that. Where is it?
Yes.
Yes. the Prestea Golden Star came up with a mechanized version of this particular technique, and they were using a machine called the Alimak, and this Alimak was kind of tries to follow, you drill a pilot hole through the deposit, and then you now use the Alimak as your platform and stand on it and do the drilling above. So you drill along the whole of the vein. They were dealing with vein deposits, so they drill along the whole of the vein, and then they do their blasting. Usually, this is one of the outmoded methods that was in place when we used to do some of these things by hand. Okay, we used to do these things hard labor, manually. So that is how come we have the mechanized version that was introduced by these people. But at the end of the day, I learned they had to switch to a different technique because this was giving them a lot of trouble. And the trouble here was that they were dealing with vein deposit. So at the end of the day, they blast the material and they have a lot. They wanted to take advantage of how thin the deposit was, and then they erect their Alimak along the deposit. But then the Alimak was almost or more a bit wider than the vein deposit. So at the end of the day, they end up including waste. And when there is waste in this thing, we call that dilution. Let's say you target 30% ore and you finish and you have 50% ore. It means that there have been some waste introduced into the ore you are interested in. And so they end up all the time having a lot of waste material coming into contact with the ore they want to mine. And then they go to about 150 meters. That is how long they can drill using the Alimak. And this one introduced a lot of stresses into the wall when they are mining. So at the end of the day, the caving and other excesses wasn't making the method beneficial. So this method is actually mechanical when you are dealing with small sizes of stone, which you think you can manage. And if you want to mechanize it, then unless maybe the people who introduced the Alimak, they go back and revise how they can make this Alimak better for other mining companies to adapt and continue to use the shrinkage method. So the long hole it's also in a form of another drill or another mining method where you do all your levels and all the necessary development process, you put them in place, and then you stand on one of the levels and you drill at a very long distance. And you begin to blast them, blast the holes. So it says that apply to lower 100 meters and longer diameter holes. So you drill large holes into the ore or the deposits that you are targeting, long holes, and then you blast and begin to fetch the materials through the loading or the draw points you have created when you were doing the development. That is how this is. So at the end of the day, one disadvantage of this one behaves similar to, what's the name? The long hole. So when you finish with this particular deposit, one of the issues you encounter is that it behaves just like how the Alimak will leave a long or a very big space for you. And usually when you have those huge spaces, it is a disadvantage because you are imposing or you are inducing so much stresses onto the walls. That is how come when we have story buildings, we have certain heights we go up to and we floor the top of the building. Because if you go too high, there will be stresses within the wall and your building will not last. So in the same way, when you are underground and you are trying to create that space where you are working, you need to be cautious, taking into consideration. So before you can go for this type of long hole or long wall drilling, you have to be very much sure that you have a very competent country rock, and at the same time, the ore you are dealing with is also quite strong enough to till that period when you are doing your activities. Then we have the vertical creator. The vertical creator also behaves similar to cut and fill. Cut and fill, just that this one, you drill, you stand on one level and drill to the other level. That's just the difference. Cut and fill, you will be in there, drill or try to finish a whole block of ore and fill the platform. This one, you are going to fill the whole stope, but this time around, it behaves like the long hole where you drill from level to level and then initiate the blast, and all of the material within that hole will begin to break down for you to fetch. And when you are done, you fill back the space as in this particular situation. So this is the filled block of all you took. You took it from here, and now you have filled the portion. Then you go onto this other one and you begin to work. That is how this one also behaves. So you mine them, but then from level to level, you clear it and then fill that slot off and go to the next one. Then we have long wall stoping. So long wall and then long hole stoping, they behave the same way, just that the difference is the wall, how long you are going to leave that space. So if I want to create a long wall stoping, I have to be drilling long holes, but then this one, the wall will be long, but I'll be dealing with it in bits by bits. And at the end of the day, I get the space. But this usually, this particular long wall technique is used in coal mining. So we use this technique when we are dealing with coal most of the time. Yeah, so coal mining, and I have a video of it. I want to show how the coal, in coal mining, we use the long wall so that we can appreciate how it works. If we had met face to face, I had a series of videos I could have shared with everyone so that in your leisure, you can just have a look at these videos. They are very interesting to watch. But then once I have your email after the class, when we are done, I'll try to compile them I'll compile them and then send them to everyone. Let's watch this video carefully and see how they are operating after we discuss it. So in this aspect of the long wall we are discussing, this one, the wall is not in the form of its vertical height, but then we are talking of the horizontal. So, and then usually we use it when our deposit is soft enough to use some of these heavy equipment. So we try to create a wall, artificial wall along that deposit. So this one is used when we realize we have a deposit, what that is an overburden of a certain thickness, which we think wouldn't worth it extracting the whole of that overburden material. So we develop the place and we start from a far end and begin to be extracting. So as we move along, we'll be extracting the material, and then it will be loaded onto a conveyor belt and taken to our usual location for processing. And then whilst we move backwards or we go along, we'll be taking the artificial support we provided. And so you see that the whole of the overburden will begin to fall onto the ground where we have scooped the coal from. So watch how the roof is done. So you see these cylinders or these machines over here, they are the ones providing the roof for the conveyor belt, and then the machine itself that is doing the scooping. So whilst you scoop the material and you are about exiting, one of these cylinders will shift forward and provide the shade. And so whilst we move along, it will be falling behind us. That is, the overburdened material will begin to fall or kind of subside onto the place where we have already scooped the coal from.